For this part, we will introduce the root summarization. Actually, the root summarization is one of the OSPF advanced features. Okay, so let's enter into the root summarization. So first, we will focus on the concept of root summarization. Actually, the root summarization, we also can call it root aggregation. So it means we can summarize a group of detailed roots into one summary root. For example, such as on the router, we have the 192, 168.1 and this segment, right? And for we have also the 2 segment, and then we have 192.168.3.0 this segment. So we can summarize this many detailed rules into the 192 and 168.0.0. Okay, we can summarize the detailed roots to the summary root. So this is the root summarization. Okay, so actually for configure the root summarization, and it can decrease the routing table. Actually, here in the routing table, we have 3 detailed roots, but after the summarization, actually we have just one summary root. Okay, and for this, actually, it also reduces the resources of our routers, because if we want to store more detailed routes, we have to occupy the memory or the flash of our router. So if we use summarization, actually it can help us to reduce the memory or the flash resources. Okay, so it is a helpful way for us to manage our routers and manage our routing tables. Okay, so after this, we can see we have the 2 ways. Okay, we have 2 ways for OSPF support menu root summarization. First is summarize for inter-error roots on ABR. Okay, and another is summarize external roots on ASBR. So it's 2 ways for you to do the summarization. And now for next page, we will learn the OSPF router summarization case. For this case, actually, here we can see the topology here. And in this topology, we have the 5 routers. And for the R1, R2, it belongs to the area 1. And for the R2, R3 belongs to the area 0. So the area 0 is a backbone 0. Okay, and for the R3, R4, R5, it belongs to the area 2. And the R1 has a segment for 10.1.1.0 and the 10.1.2.0 and 10.1.3.0. So there are 3 detailed rules information on R1. And then for R5, on R5 we have the 172.16.1.0 and 172.16.2.0 and 172.16.3.0. These 3 detailed routing information. Okay, and when we enable the OSPF on R5 and R1, we have to do the network, and then for the 3 network, we can learn from the R5. And then for the R1, actually the 3 detailed routing information is directly connected with R1. So we also have to redistribute this routing information into the OSPF domain. Okay, so this is the topology basic information. And for this topology, actually we can see for the R1 device and the R5 device, we have so many detailed information in our routing tables. So if we advance this detailed information into the OSPF domain, and every router will learn this detailed information, right? So for every router, we occupy the memory to store this detailed information. So if we want to save, or if we want to decrease or reduce the resources of every router belongs to the OSPF domain, we can do the summarization on R1, right? Okay, we also can do the summarization for the R5 for this detailed routes. Okay, so next page, we will learn the summarization. And here is the first scenario for route summarization on API device. So here we can see inter-area route summarization can only be configured on API device. So here for this topology, we have two API devices, right? One is the R2 device, and the second is the R3 device. For the two routers are all the API device. So which device we have to choose and then configure the summarization. So here is the answer. The API can only summarize internal routes from directly connected areas. So for these answers, actually we will know if we want to do the summarization for internal routes. So we have to do the summarization on API device, which is directly connect with the areas. It means here we can see for the R2 device, the R2 device is belongs to the area 1 and the area 0, right? And for the R3 device, it belongs to the area 0 and the area 2. So actually, if now we want to summarize the detailed routing information is 172.16.1.0 and 172.16.2.0 and 172.16.3.0. These three detailed routing information. Okay, so actually the R5 is belongs to the area 2. So the R3 is the API device belongs to the area 2. So we just can do the summarization on R3 because the R3 and R5 devices belongs to the same area. But for the R2 device, it not belongs to the area 2, right? So we can do the summarization on R3 device. So how to configure the summarization on API device? So here is the command. We can see this command is router OSPF1. We add into the OSPF process, and then to comment the area 2 range from the 172.16, and then segments will summary as 0.0, and the net mask is 16, right? And set the cost value is 10. So this is the command for summarization. So we are adding to this command on R3 device, and then the R3 device will deliver the type 3 RSA information as the 172.16.0.0, this information into other area. So for the R1 and R2 receive this routing information, and we can use the command with the show IP route OSPF. And on R1, R2, we can see the summary routing entries, but we can't see the detailed routes in our routing tables after we configure this command on R3 device. Okay, so if root summarization is executed on R2 device. It means we configure this command on R2 device, so the required effect will not be achieved. It means we can't see the root summarization successfully because the R2 device is not belongs to the area 2, right? Okay, so we just can do the summarization on API device, which is belongs to the area directly connected with the areas. Okay, so this is the first scenario for summarization. Okay, let's go on for next page. So for this page actually introduce the second scenario for summarization. So we can do the root summarization on ASPI device. So here for this topology, we can see which device is the ASPI device, which device is the ASPI device. So here in this topology, the R1 device actually is the ASPI device, right? Because the R1 connected with the OSPF domain. Here is the OSPF domain right here, and then connected with the external routing. So here is another AS, and here is another AS, right? Maybe we can enable another OSPF process on R1. Maybe we just to configure static or other protocol. Okay, and so the R1 can learn this three detailed routing information is 10.1.1.0 and 10.1.2.0 and 10.1.3.0 for these three detailed routes. And for these three detailed routes, if we want to do the summarization, and we have to do the summarization on ASPI device. So for R1, it's an ASPI device. Okay. And for the external routes, how to configure the summarization. So here is the command, and we add into the root OSPF 1, and then enter this command is a summary address, and the summary segment is a 10.1.0.0, and the net mask is 16. After this command, we just can see the summary routing information in our test. So now the R1 device will deliver the type 5 RSA information to other device. And in other device, we can use the show IP root OSPF, right? And we can see the external routes for type 5, right? For the type 5 RSA, but we can't see the detailed information on the device. We just can see the 10.1.0.0 this segment on our device because we do the summarization on R1 device. Okay, so for external routes, actually show IP root OSPF, we can see maybe the OE1 or OE2 this routes information in our routing table. Okay, so for next scenario, and for this page actually introduce the third scenario for route summarization on the API of the SSA area. So as we know, the SSA area is a special area, right? And for an SSA area, if we want to set the area to become the SSA area, we have to enter the commands on R1 and R2 device, right? Set area 1 and SSA, right? For this command, and to set the area 1 to become the SSA area. Okay, so after we configure the area 1 to become the SSA area, so what happens next? So now for the R1 device, actually is an ASPI device, right? And then we will do the redistribution on R1 device. and to learn the 10.1.1.0, 10.1.2.0, 10.1.3.0, these three detailed routine entries, right? And then for these three detailed routine entries, and we will transfer the information to auto device, right? And for this transmission, actually, we will generate the special RSA information as a type 7 RSA because in an SSA area, the type 7 RSA will generate. Okay, but actually for other area device can't recognize the type 7 RSA information. It just can recognize the type 1, 2, 3, 4, 5, right? So the R2 device is the API device belongs to the SSA area, right? And so that in order to other device can recognize the RSA information from the SSA area. On R2 device, we will convert the type 7 RSA information to type 5 RSA information. Okay, so here is transmits the type 5 RSA information. So now, if we just transmit the type 5 RSA information, so for R3, R4, R5, this device can see the detailed routine entries, right? And now, if we want the other device just can learn the summary information, so we have to do the summarization on R2 device because the R2 device actually is the API device belongs to the SSA area. So here we can see the command is ending to the OSPF process and then ending to the summary address 10.1.0.0 and the net mask is 16. After this command, actually, for these three detailed routine entries, we just can become one is a 10.1.0.0 and the net mask 16 for this segment. And for this segment, actually, we use the type 5 RSA information and deliver this information to the area 0 and area 2. And on R3, R4, R5, we use the shoe IP route OSPF. Just can see the 10.1.0.0, the summary routine information. Okay, so this is the summarization for special area. Okay, and next. And for this page, actually introduce the loop prevention. If the loop happens in our network and we do the summarization cause the loop happens. So how to solve this problem? Okay. So why the loop will happen? So first, let's see the topology. Here, actually, we do the summarization on R3 device, right? Okay, on R3 device, we do the summarization. And on R5, we have three detailed routes. And we want to summarize the information into other area, and we have to do the summarization on API device. So here we do the summarization on R3 device, and then the R3 device will generate the type 3 RSA information to R2 device, right? And then after the R2 device receive the summarization routing information and add it into the routing tables, right? And then what happens? So now we can see in the network, we have just one PC want to communicate with the destination is a 172.16.11.1. Okay. And for the R3, R4, R5, we also have a default route. Okay, we also have the default route. So we can shoot IP route, and then we can say the 0.0.0.0. We can say this default route. So now, as a PC and want to communicate with the destination, and we can see the destination actually belongs to the segment 172.16.11, this segment, right? Okay, and the source IP is 192.168.1.1. So actually, this PC is a irregular PC, and the PC sends the packet to R5 because the R5 is the gateway for the PC, and then the R5 will check the routing tables and he finds if we want to communicate this destination, he have to transfer the packet to R4 device. Okay, including the default route. And then for the R4 device, he also send the packet to R3 device because the R4 finds I have the default route and then the next hop is R3, right? And for the R3, actually the R3 will check the routing tables and send the packet to R2 device, including the default route. But now for the R2 device, actually the R2 device have to check the routing table. And for the routing table, actually we will see the summarization routing information is from the R3, right? And then the R2 device will transmit the packet to R3 because of the summarization route. So now the R3 receive this packet and then check the routing table and he find if the R3 want to communicate with the destination, this segment, right? And the R3 actually have to transfer this packet to R2. So now the loop happens, right? And as we know, actually, the destination IP is 172.16.11.0. For this segment, actually, is not included in any device, right? Because in this topology, not anyone the device has this IP address, right? So now the R3 will transmit the package R2, the R2 will transmit the package R3 again and again, right? So what happens next? And we will know in the packet and the network layer, we have one parameter called TTL, right? Called TTL. It's time to live, right? Time to live. It means how long your packet can live, right? Can live. So the value for the TTL is the 0. It means the packet is dead. So for the packet transfer between the R2, R3 again and again, and what happens? So the TTL will decrease, okay, such as from the 16, right? From the 16, and then decrease one by one. And if the value choose the 0, and then the device finds the packet TTL value is 0, we'll discard this packet directly, okay? Because the TTL means this packet time to live, okay? And then what happens? For this progress, actually, the R2 and R3 spend much time and spend much resources to deal with the loop because every transmit will occupy the bandwidth, will occupy the link resources between R2 and R3, right? And for the R2, R3, want to transmit this packet, actually, he have to check the routing table. He have to deal with this packet and find the source, the destination, and then to match the routing table. And the R3 and R2 have to find the next hop, the interface. So the R2, R3 actually with much CPU resources to deal with this packet. So here we can see there is just only one device in our network, right? So if like this irregular pieces has too many in our network, so the loop will waste much resources in our network, maybe cause the network problem. Okay, and even though they can waste the CPU and the memory, of course, the deal with speed of our routers. So this is a very serious problem, right? Okay, so how to deal with this problem? So we can see the solution. Solution is if we do the summarization on the device, so the root will generate on the device, but the root actually is point to non-zero. So what does this mean? And here we can see we use the should IP root, we can see the non-zero roots, right? It means use the summarization on the device. On this device, will generate the root, and the root actually will point to non-zero. For the non-zero, actually it means we will point to myself, but for this interface actually can't deal with any packet. So for this packet, if this packet transmits to the non-zero, and we will discard this packet directly. Okay. So now what happens next? If we do the summarization and generate this non-zero root, and we can see now the same action, and the PC sends the packet to R5, right? And the R5 sends the packet to R4, and then R4 sends the packet to R3, and asks the R3 want to communicate with the destination IP, and then we will check the routing table, right? And we will find actually we have the roots. It's a 172.16.0.0, and then the next hop is a non-zero. It means if we want to communicate with the destination, we have to transfer the packet to non-zero, this interface. Actually, the non-zero is point to myself, right? It point to myself, and because the non-zero can't deal with the packet, so the S3 will discard this packet directly. So the S3 don't transmit this packet to the R2, and the loop actually doesn't happen. Okay, so this is the solution for OSPF summary. Okay, so this is the part for root summarization, and we introduce the different scenarios to ABR do the summarization, to the ASBR do the summarization. Of course, we actually introduce the special area, unnecessary area to do the summarization. Of course, we also introduce maybe the problem where happens after we do the summarization, like the loop, right? And for the OSPF, how to serve the loop after we do the summarization. Okay, so that's all for this part.